Okay guys, so today we'll be talking about functions and nested loop. So you should know more about function and nested loop. Nested loop is just a loop inside a loop, like a while loop inside a while loop, a for loop inside a for loop, a while loop inside a for loop, like that, right? And then functions is like a block of code that perform a specific function or a specific task, because we can't use function in functions anyway. Okay, so you should go through all these materials, and in this one we'll be talking about the quiz section. So let me just quickly open it and let's dive into it. Okay, so the first one is 12 modulus 3. That's 12 divided by 3 is what? It's probably 4. Remainder what? 0. So your answer is 0. So modulus is the remainder after division. Okay, so the answer is 0. So the next question is which of this is not a loop? We only have three loop, we only have for loop, two while loop, and while loop. So every other ones, this one, so the each, the for each, the loop two, they are not loop in C, right? So by the time you do 89 divided by 7, the remainder will be 5. Okay, so I think that should give you 84 is what will go, and yeah, the remainder will be 5. So the ASCII value of 0, so if you want to write 0 using the American standard for what's this guy called? So if you are representing it using ASCII value, you use 48, and then this one you can just search for ASCII table and you'll be able to see all these values inside them. So the ASCII value of 5 is 53, and then the ASCII value of dash is 45. The ASCII value of A is 97, that's small letter A. So there's different value for small letter and capital letter. So for J is 74, and then if you do 12 divided by 10, you know it gets 1 remainder 2. That's why we have 2. And then this one ASCII value for capital letter A now is 65, and then if you do 12 divided by 2, you get 6 remainder what? 0. Okay, so that's how it go down. So that's that on that. Okay guys, so we are going to be doing the tag 0 on this function and nested loop. Okay, so the first question says write a program that prints underscore put char followed by a new line. Your program should return 0. We could just use printf or put to do this, but it's not going to work. I think we have to use put char, not more than twice. So in order to do this, there are other ways to do it by first writing a function that acts like put char, and then calling it inside calling the function inside a main function. So that one is like a long process. Okay, so the easiest way I've come across, okay, is to first let's create this directory, and then we would vi this file, and then we'll be able to solve it together. Okay, so copy this. Okay, so we have our web terminal here. Let me list it. Okay, so we'll seed into our ALX low level programming, right? And then if we list it, you have all the things we have, then we'll make a directory, right? Okay, so let's seed into that directory, right? So if we ls, we have nothing there. So let's clear it. So the first thing you want to do is create a readme, right? Readme.md, sorry, .md, right? So you can just write copy about the project, like the title, all these things, blah blah blah. So let me just put this one as the title. Okay, just for simplicity. And then I'll just say, sorry, um, okay, let me escape. Alright, so we have our readme there now. So I want to create the file that I'll be using, right? So I'll just come down, and then where is it? Yeah, so 0 1 dash picture.c. So there are, like I said, there are two methods to solve it, and I explained the first one, even though you might not understand now, but it's quite simple. So the first thing is I want to include um, my stdio.h, and then what do I want to do next? I want to write the description, and the main it should print underscore picture, right? So we have our return value should return 0, and then we have our int name which should be void for now, and then this is where our code will enter, right? So the first thing I want to do is I want to declare a variable int, and I want to call it we could use an unsigned int though, but let's just create int, and then let's give it I, right? Int I. So I haven't initialized it yet, so we can have another char to save our so I'm going to create an array of char, right? So I'm going to then initialize it here, and then I'll write put char. So what I've done is I've given this C to save this whole put char, and this one is showing that it's an array that can store more than one character. Okay, so now I have 1 2 3 4 5 6 7 8. So 0 1 2 3 4 5 6 7. So in character, in array, we start from 0 1 2 3 4 5 6 7. It means this is in position 0 inside the array. So if I see 0, it's going to print this underscore. Okay, so what I'm going to do next is I can use my while loop and I can use my for loop. So for this one, let me just use the for loop, okay, because I've been using the while loop so much, so you get used to the for loop as well. So like I said, if we are using the for loop, we'll first initialize it. So I want to use my I. The thing is, I want to print this 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8, right? So I'll say I equals to my I equals to 0, right? So I'll say I equals to 0. Then the next thing I'll put my condition. As far as I is less than equal to 7, and less than equal to 7 is it means that, okay, let me put space here. Yeah, it means that our loop will go 8 times, because it will start from 0 1 2 3 4 5 6 7. Okay, it's going to go 8 times, and then we'll do I plus plus. That will increment it, right? Then inside our block of code, we want to be printing that character one by one, right? So I'll just come here, and then I'll say it should print, but I think we are to use underscore put char to print. So if we're using underscore put char to print, it's gonna be easy. But anyway, underscore put char. So we have our C. Um, let's see if this guy work. CI. I'm not sure. Let's write. So we are supposed to just, let me just put char, because I think I have to read that instruction one more time. Put char. So what I'm saying is this one, it will replace it with 0. It will print it. It will replace it with 1, like that, continuation. And let me come here and then print my new line, right? And then my return value. Okay, so let's test this guy and see. So if we do Betty 0, so So Betty said we are good. GCC 0. So it has compiled it. So if you do ls, we'll see it. Then let's run our a dot out. A dot out. So we have our underscore picture printed in with a new line. But I think we'll have some issue. But for now, let's git add and git commit. So we git push. So let's see if it works. I'm very sure we'll have one error because I think there's something in the instruction that we also have read. And let's see. Yes. So if you look at it, we have some errors, right? Let me see if it give us some details. Okay. So the files 0putcha.c and main.h are present. So the thing is we have to have an header file, okay? We have to have an header file. So if you read the instruction from beginning, okay, it says that okay, so you are not allowed to use any of the standard library. Any use of function like printf put etc is forbidden. So we are not allowed to use the standard library. So you are allowed to use putcha. So you can only use this putcha. So let's see if putcha has been declared for us. Okay, so we first check if it has been declared. Okay, so that one is loading and let's continue reading. So that's why it's kind of important to read it. So that's the only reason. So it worked perfectly, but because they told us not to use putcha, but they told us to use another type of putcha, which is underscore putcha. Okay, so and that underscore putcha, okay, the normal putcha you are doing in the standard library, it has been defined, right? So we are going to use another header and then define it inside that header. You understand? And then we'll be able to use this underscore putcha. So the definition is what they should have provided for us here. Okay, so I think that's what we'll copy here in order to do it. So it continues by saying that in the following example, the main.c file are shown as example. You can use them to test your function, but you don't have to push them to your repo. So we can use the main.c provided down to test our function. So main.c file, our main.c file might be different from the one shown in the example. So the prototype of all your functions and the prototype of the function pusher should be included in your header file called main.h. Don't forget to push the main.h. Okay, so yes, so this is it. So we have this stuff declared, right? We have this underscore pusher this declared. So we'll first copy this guy, okay, copy it and then write a file called underscore putcha.c on your stuff. So let's go, then you do ls, right? So we do vi underscore putcha.c, okay, then you paste this guy there, right? Then escape wq, okay, ls. So let's Betty it and see if it meets up with Betty. Sorry, Betty underscore putcha dot c. Okay, so I think it's working. So Betty say it's good. So good. So the next thing we are going to do is we inside this zero putcha now. We don't want to use that standard like IO. We want to use another header, okay, so that we can change that putcha to underscore putcha. So in order to do that, we'll create a main.h Okay, so vi main.h, and inside the main.h, our main.h, there are some intro you can add to it here, but for now forget about the intro. So our main.h, these are the prototype, so just copy the prototype for this one. Okay, and paste it here. So for now, just paste it and end it with a semicolon. Save it. So okay, so when we list it now, we have 1 2, so we have this 1 2 3 for now. Forget about this a dot out. Okay, so the next thing is we'll go into this zero picture, and then we'll replace it with main.h, the header file. So we'll say vi zero picture, right? And then this includes standard IO. It will now be include then we have our main.h, right? Main.h. Okay, so this is how it's going to be. So we have our main.h, and then all this one now is called underscore picture. So since we've done this, there are two ways to do this. You can just do underscore picture. Okay, I'm coming. You can do like this, underscore picture. Okay, so you can do it like this, or just come to this place and then put underscore picture. You write this thing in 8 places, right? Underscore picture, open bracket, close bracket, and then colon like this in 8 places. Okay, so you can do it in 8 places. Probably I'm going to do the second method for you now, so you see. So I want to copy this guy, or don't worry, I will duplicate it. Okay, so let's do this one. So if you Betty it, Betty 0, right? So it's working, and let's compile it. It says on define reference to underscore picture. Okay, what happened? You defined it now. Let me VI into underscore. We've already defined this guy. What is this guy telling us? I don't think we have any. I don't know why it's giving us error. I'm trying to look at. Well, let me clear. So I think Betty worked, right? So it's the GCC that is not compiling it. Okay, let me try and see the compilation here. Let me compile using this guy. Okay, this one compiled. Okay, so when we do ls, okay, so we have our this one now, right? So let us compile, let us execute it. So when I run it, can you see this printing underscore picture, right? So it is working now. So you can do it that way. Another way to solve this first one, okay, after you've created this main.h, right, and you've created this underscore picture, right? So you want to create this guy now. Okay, so let me just copy that guy, or let me just, okay, let me git add and git push and check the code first. Okay, git add, git commit, and then print. Is there something that I don't want to push here? Yes, I don't want to put. Okay, I've already added it. Anyway, git commit. What do you want to do? Print underscore put jar, right? And then git push. Okay, so if we do this one and check our code, it should work now. But I'm going to show you another way in order to solve this particular task. If this once this one works. Okay, so it's still loading. It has worked. So another way to solve this guy is to just come to your. So I said um, after you've created this main.h and underscore butcher, right? So you want to create this one. So let me copy this guy. Underscore butcher.c, and I want to call it test. Okay, so I'm calling it test.c. Okay, so ls, so vi test 1 2 3 4. Okay, so another way, this one is kind of hard. Okay, so this one that we are doing is now simple. Okay, so this one that we did before is like the add method. So let's do a very simple version. Okay, so you just clean everything. Okay, so let's open the brackets, and then so you just do underscore put jar underscore put jar 8 times, underscore put jar underscore put jar underscore put jar underscore put jar. How many have we done? Let me do one more count. So this is 1 2 3 4 5 6 7. So I think it will be one. Okay, so what do you want to put? So want to print underscore put jar, then inside those, then you have your 1 underscore 1, or let me just, for simplicity, let me just use 1 1 single quote single quote single quote single quote single quote single quote. Okay, so the next thing is just inside that single quote you put your underscore butcher underscore. We've done it for the first one, and then p u t c h a r. Okay, so we can do it this way, and then if we let's betty it, betty test dot c, betty say we are good, then we'll compile it using that method. Where is that method? Oh yes, it's not compile. Where is that method? Let me see if I can access it. Yeah, so this is it. So I'll just change this place to test.c, and then this one to test.c. Am I sure of this thing? Then output to test.c. I know it's not going to work. Wait, I think this one should be underscore. Sure. Where is that guy? Let me just check here. This is underscore pucha. Let's see. Okay, I think that's the file name there. So this one is 1 2 3 4 underscore pucha dot c. Okay. It's still not working. I think it's just because of the name. So test.c is the same as the output file. Okay. So I think this one should work. Let's just use a test. Okay, so it worked. So now if I do ls, I have test as well. So let me run test. You see it printed underscore pucha, but I didn't add new line to it. So let me just vi test.c. So you just add new line to it as well. So this is another method to solve this particular task. So you can just do underscore put char, right? And then when we compile it again, right? Test it. Can you see it's printed put. So I think this one too, if you push it, it should work. So see you in the next question. Okay guys, so in this lesson we're going to do the second task, which is number 1, and then it says write a function that prints the alphabet in lowercase followed by a new line. So now, before we've not been writing functions, we've been writing functions but inside the main function. But now let us write a function in which it can be called into our main function. You understand? If you look at this main function now, that's what they did. They called that function that will create into the main function, and then when they call it, it will just execute abc to z. You get? So we have to create this function. Okay, you can only use putchar underscore putchar because we've defined underscore putchar to be able to print like the normal putchar, so we can use this guy right in the first question. So the prototype is like this. Okay, so they've given us like the heading of the stuff, so it will not have a return value as you can see, and it has no parameter. That's why no parameter was passed to it here. You will understand this better probably once we have the online class. Okay, so basically what we'll do now is um, we are creating the uh, the function, and then we'll pass the prototype into our main.h. Okay, so basically that's just what we intend to do. Okay, so the first thing we'll do, so let me go back here, and before I even copy this, I want to copy my file name, right? So one alphabet.c. So this is where our functions will be declared, right? So the first thing is go to, so let me close this one since we're not using it again for now. Okay, so let's vi and this, and then we have our I, then we'll include our main.h. Don't forget it's like this, not this one. So we include our main.h, go to the end, and then we start it, and then write main, right? This one will print alphabet. So we'll change the name from main actually, but I will show you why we should change it. But let me just continue like this first. It should return, it has no return, right? So return should be probably void. I'm not sure if I'm going to declare any return type for it. So since it has no return, let me just exit that one and just that this should be the end. Okay, so we'll copy that prototype because that's what we'll use to continue our stuff. So they've given us like small expo in order to work. So we'll do this. So instead of writing int main void, so we just use this one to continue. Then we do this, right? So they've helped us here. So remember when it was int main void, this place was main. So this place will now take the name of this place. So it will now be print alphabet. Okay. So this one is going to take for print underscore alphabet. Okay, so that will be that. Okay, then we'll have our function now, just like before. So we want to create a function that will print alphabet. We've done that before. Okay, so let's just create a character and call this one alphabet, right? Al. Okay, so we can use our while loop and we can use our for loop. Okay, so let's just use our while because that's basically what we used before. Okay, so and then we say while, then we declare our al. Okay, you can declare it here on top. Let me make sure there's no space there. Okay, so while al, so we want to print alphabet equals to a, equals to small letter a, right? Equals to small letter a. So while this one is this, you can use for loop to solve this one as well, like we did before. So give it the condition that al is less than equal to z, right? Okay, so then you should print underscore. So we are using underscore butcher to print now. Print um print what's it called? Print al, right? So I think that should be done. And then so go to the next one and increment al plus plus, right? Okay, then we put our underscore butcher to print a new line, right? And then this and then no return type. So this should be it, right? So we will not have any return. So inside our main, this signature here, we are going to put it inside this main.h. Okay, so that um, whenever we have our main.c, okay, so if we have main.c and then we'll put this main.h inside our main.c. As you can see here, this one has the main.h. So the main.h will house all this signature, okay, so that whenever they use this print alphabet inside that main.c, is going to, this main.h, since it has the signature, is going to perform that task that that function is meant to perform. Okay, so where's it? So what do we want to do? So we want to copy this. So let me first exit this and then ls. So I'll go to my main, I'll vi into my main.h. Okay, so we have this one before, and then insert mode. Do I still have this one copied? Okay, so we still have it copied. So I'll leave it like this, and then we can test our program using this guy. Okay, so we can put this, we can have one main.c, copy this thing, paste it there and see if it's going to work. Okay, so we could just do it. Let's test it so you can see. So we'll do one main.c, copy. So if we vi one main.c, I will delete it once we're done. Okay, so let me just copy these guys to this place, right? Copy, paste, escape. So let's gcc one main.c. It might not work though. If it doesn't work, then we'll use that we'll use this guy to execute it. Okay, so let's copy this guy So we'll have it as one alphabet also, right? The alphabet is one alphabet. So when we enter it and then we do ls, so we have that one alphabet. So let's execute it. So you have it. Okay, so let me delete that one alphabet because I don't want to push it. So I want to remove one alphabet. Okay, and then I want to remove, let me remove this text and remove this which one again, main.h, one main.c. Should we remove it? Let's remove it. One main.c. Okay, so far we've created one alphabet.c, so you can use the for loop as well. So let us clear, let's git add, and let's git commit, and give function that prints lowercase alphabets, right? And then let's git push it. Okay, so let's check our code and see if it works. So we've checked, and that will be all for now. So let's go to the next question. So in this lesson, we have to do the third tag, which is number 2 10x alphabet, right? So we have to write a function that prints 10 times the alphabet in lowercase, followed by a new line. So when the function is passed into a main, as you can see, it executes it 10 times, okay? So the thing is, you're not supposed to, you can only use put chart twice, and then so it's followed by a new line. So it means one picture will go for a new line, and then the second one will be for the code. So what we're going to do is we're going to have a nested loop in which one loop, which will be inside, will print the A to Z, and it's going to use this picture to print. And then the second loop, which will be outside, will make that loop go on 10 times. Okay, so in order to do this, let's go. So I'm inside my program already, and then I will just vi the name. So let's copy the name of the file that I'll be using. So okay, so 2 alphabet.c. I hate using web terminal because sometimes the network just sees and then you have to reload and all those rubbish just happens. So I've okay, so we include our main.h, right? Then we describe the program. So the name, instead of main, we're gonna have the name of the, so the name, you remember main used to be here, but now it's the name of the function. Okay, so post the name of the function there, and then you say prints alphabets times 10, right? You can add a description if you want. So the description is probably using, let's go picture to print. It's not going to return anything, so I'll just leave it like that. And then we can copy this full prototype because that will be the heading of our function. So place that there, we remove this guy, okay, and then Yes, we have this like this. So the next thing we want to do is we will declare a character to hold our character. We can declare an integer j to hold our outside loop. Okay. So we can use the for loop or the while loop. So for now I'll use the for loop, and then I'll declare it this way, right? So I'll say for loop. I'll So this is the for loop that will make the code execute 10 times, right? So I'll use j, sorry, j as long as, so j is equals to what? We give it 0. So as long as j is not is less than 10, so this will make it go 10 times. Okay, and then we say j plus plus, right? So then what should it do? Then you should come and execute the code. So for the code, I'll do a for loop again. You can use while if you want, right? So you can say for I, which is a character, is equals to what? A. So we do this way, right? I equals to A. And then as long as A, which is I, is less than or equal to Z, right? Then I plus plus. Okay, so we'll come and execute the code here. And then so we'll put our put char, right? Don't forget it is underscore put char, underscore put char, and then we have to print our I, right? So we are printing I. So at the end of the loop, you should, once you print A to Z here, you should print a new line. So we have our underscore put char the second time, and then we should print a new line, right? Sorry. Okay, so print a new line, and then we are not going to have any return type, right? So what this one does is going to print A to Z first, and then this one will be increment by 1. This one will make it go 10 times. Okay, so with this we should be good. So the next thing we're going to do is that for it to work in the main.h, we have to put the signature inside the main.h file. Okay, for it to work in the main.c. So main.h, right? So what I'm going to do is copy the prototype. Okay, I think it's even copied before, and then let me go to insert mode, and then I'll paste it here. Okay, escape, and then just clear. So what you can do to test your file is go here, and then we can create a file called main.c. So this one is just for us to test the file. So, or sorry, I'm supposed to use Betty to confirm if it is right? So Betty said we are good, right? So okay, so before we compile it, let me then create my main.c, and then I'm going to copy all this in order to test the file, right? So copy this, paste it. So let's compile it, right? So compile it, right? So compile. After compilation, we list it. So we have this one. So this is what we execute. So when we execute it, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So let me clear it, and then let's list it. So I want to remove this two, remove that two alphabet, and then two main.c, right? And I think that's, I don't want to push it. We don't need to push it. So let me git add and git commit, and call this one print alphabet 10 times, and let me git push. Okay, all right. So let me check my code and see if it works. Okay, so let's check. So it has worked, and let's go. So that'll be all for that. See you in the next video. So we're going to talk about the fourth task, and then in which is number 3, is lower. So we have to write a function that will check for lowercase character. In the sense that when you put that function into this, then it's going to know if you have lowercase or not. So I think this one is uppercase. So we have 0, and then I think lowercase for 1. We'll know. So it said return 1 if C is lower, you see, and then it will return 0 if it is not. Okay, so that's why it means um, uppercase, lowercase, lowercase. That's what we want. So write a function that checks for lowercase. So this is the prototype, right? So first, let's just put this one into our main.h, right? And then we'll write the function. So we'll go here, and then let's list it, and then vi main.h, right? So I, and then we'll paste this guy here, right? Let's save and edit it, right? Good. So let me clear my screen. So next thing I want to do is, sorry, I want to copy the file name. Because it's called 3 slow, right? So I'll copy it, and I'll come here and I'll paste it here. So the next thing I want to do is write our include. So we want to include that main.h, and then we write our description, right? So in order to write our description, we need that header file, header signature again, function signature. So we need int is lower, so it is underscore is lower anyway. So let me just paste it here and remove all the SS that I don't need. So this one is going to return an integer, right? So okay, so this one will detect lowercase and uppercase. You can give it a description that says use underscore picture to print. That one isn't necessary. We're going to have a return type, so let's write our return. So our return type is going to be 0 when what 1 if C is lower. So let's do 1 if C is lower, otherwise what's 0. Then let's end it here. So let's copy paste that prototype, and then come here, tab. Okay, so basically that's that. So now I want to create a function that, look at it, returns 1 if C is lower. So we're going to have an if statement, and then a 0, so the return. Okay, so we can say so if C is lowercase, okay, and then Return one. Alright. Okay. Sorry. So let's create a character. Okay, character hi, and then let's create an int, and let's call it lowercase, right? We can declare it for now to be 0. Okay, so let's create our for loop, and I will explain once I'm done. Just like we've been doing, and then we want to know if it is lowercase, right? So we'll first create the lowercase, right? So I'll say for I equals to, so this one will create the ABC for us, right? A I is less than equal to Z, right? So for the Z, I will write it this way, and then I plus plus, right? So we have a if statement here. So if, so say if that I, which is A, is equals to C. So we've only said we've done uh, A to Z. So if, so it's going to come here trying to execute A to Z. So whenever this one becomes C, okay, so then you should what? You should return um, then you should return, we can just put, we can remove this lower, okay, and then just put return 1, okay, we can put return 1, okay. So another way to do that is, since we've declared lower, okay, we've said lower is 0, right? So we just say lower, you should return, then we just say lower should be equal to 1, okay. So and then we'll come outside this loop and say it should return lower. So what you are saying is it should return 1, right? Yeah, it should return lower. So if this one is lower, can be 0, lower can be 1, okay. So we are saying it should just return lower. But if that A to Z, right, once it becomes C, it should return 1, because lower is 1 here, right? So it will return 1. And then once it's A to Z without the C, it's going to keep returning 0. I think that's what we were told to do. So return 1 if C is lower, return 0 otherwise, okay. So basically that's it. And if you look at this place, okay, we didn't really see, they just pass different information to it, okay. New line picture, okay. So for this one, I won't really be testing the code because it's quite easy like that. So let me just Betty it and see. Betty 3 is slower. No description found for parameter member C. Okay, sorry. Vi, what is it called? 3 is slower. So we want to add description to parameter C. So we are going to add description to this. I forgot because I've not been doing it for a while. Anyway, this is Betty star, so Betty wants us to add it. Then to add that, you just go add C, and then you put your column, and then you say this one will collect alphabet, right? So let's escape and let's try it again. So it has released us. So let's do compile it. We don't need to compile it. Let's git add. Let's git commit. So we are supposed to test if it's going to work though. But let me just say um, detect C when it is in lower case, comma, and what prints one. Let me make it push it. So let's see if this guy is gonna work. I'm so tired. So basically what you could do in order to confirm it while that one is loading. So what we'll do, that's checked. So what we'll do is um, write create a main.c and copy this code inside. So once you copy it, compile it and run it. Okay, so should we just create it? Let's see. Though I'm tired and I don't want this video to be too long. Copy and then we'll just do vi. Sorry. Oh my god, I just pressed rubbish. I pressed Ctrl N. Now it's reloading. Okay, I want to open a new window. So sorry. Okay. Yes. So I want to paste all this. No, 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 no. Yes. Stop it. Copy. And then we'll paste it here. And then we'll come out. We can then execute the code. Then we'll pass out 3 is lower. We run 3 is lower. So you copy this, paste it here, paste it here. This is why they said so it has compiled. Yeah, it's not compulsory you push those ones. So just slash 3 is lower. You see, we have O1, which is correct, right? So let us remove that 3 is lower. Remove 3 is lower and 3 less. So we have that. So that will be that for that. And see you guys. Okay guys, so we'll do the fifth task, which is alpha. So we have to write a function that checks for alphabetic character, and then this is the prototype. Okay, so we just copy this just like the previous one we did, but this one you should return one if C is a letter, lowercase or uppercase. The last one we did was just lowercase. Okay, and then return 0 otherwise. Standard library provided a similar. So we can check man is alpha to know more about it. So let's just check man is alpha. Okay, so as you can see, let me see, it has its own int. It returns an integer, right? Wait, the last one we did, we didn't write the, okay, we wrote the return. Okay, so it will return an integer. And let me see, is there anything that we need here? We don't really need anything much here. I'm just trying to read through just to open it. This function check whether C which must have the value of an unsigned character. Okay, and then falls into a certain character class and according to the specified local function without the error. So this one is just explaining it. Okay, let's quit it and then let's go back. So we'll do it the second way. So if they pass it to this place, it should be 1110. So I don't know if I'm going to still execute and test it for this one, but let's just code it and see, right? So we'll just copy it and then do like this and vi refinement, right? So we'll have our include our main dot h, and then write our what's it called, the description kind of. Okay, so come back here. So int, so it's returning an int, and don't forget it has a c here, right? So this guy, right? And so return one when c is cap or lower. Okay, we can have our description. We are using sure, and then don't forget, wait, I think we have a white space there, so let me clean this white space. Okay, so we have our at c, so this one is collect the character. Okay, and I think that was all. So we have a return type. We're going to return one if c is low or cap, otherwise 0. Right, so go to type like this. In order to solve this, we play we did that last time, but we have one more extra for one more loop for capital letter, right? So create an each character for both lower and upper, right? And then we'll have an integer. We'll have an integer, and the integer will just we declare it to be 0 to be the return type. Okay, so for letter, right, we return the letter. Okay, so okay, so we'll give this one to be 0 for now. So when, okay, so then we can use our for loop. Okay, so the first one is to print A to Z in, let's start with capital letter, right? So, or small letter. So if our lower is equal to A, right, and lower is less than or equal to Z, right, then we have our lower plus plus. Okay, so here we're going to go through our upper as well, and then we say for, don't forget to put space here. Okay, for upper is equals to, so this one will be capital letter A, and then upper is less than equal to capital letter Z, right, upper plus plus. So if it has gone through these two, then we know. Okay, then we can then say our if statement, right? So we say if, okay, if we want to know if C, right, is equals to lower, right, or if lower equals to C. Okay, you can do that way. If lower is equals to C, or upper is equals to, I think our C should be that to, then in quotes C. So let me put this one in quotes. Okay, so I think with this it should work. Yeah, I think this should work. Okay, so it should work to return is lower. So we initialize that is lower should become lower letter, right? Letter should become should equals to 1. That's an integer, right? 1. So this one we don't need to put this guy here over here. Letter should become 1. Then we can go out of the loop. Yes. And say we should return letter. And okay, I think that's all. No more return. So I think this is all, and this should work. I'm not sure. So escape WQ LS. So we've done 4. Okay, number 4. So we do Betty 4. So let's see if we meet Betty compliance. I think we are good. So in order to test it, we'll come here and do this guy vi4 main.c, or let me just copy this guy and type that one myself. So our vi4 dash main.c, right? Then I'll paste this guy there. Okay, then let me compare. Sorry, and I'll compare. Okay, we have some errors. So okay, did I just put char first? Because I'm supposed to put underscore, put char first. In C, implicit declaration of underscore is alpha. Okay, and then we've not put it in the header file. Okay, so ls. So we'll go to the main.h. We've not, wait, have we added it? No. So we are supposed to add this guy. Right. I think we've added it. Okay, this one is lower. Okay, so we'll add this one to the header file. Right, wait down. Let me check again. vi4. Did I use underscore picture to print? Did I print anything? 4 is alpha. Okay, I didn't print anything. So let's check again. Okay, so we compare. So we have one error left. So number 11. Let me go there and see. Vi. So let's see number 11 and is alpha. It's you guys that provided it for me now. Why are you shouting? It is alpha and C has returned an int. So what's going on? So what's it going on? What's it saying? Let's see. Yes, I think we are done. We say unused parameter C. Okay, we didn't use C. Oh, okay. Okay. Let me see. VI4. Okay. Okay. It is C, not a character. So let me just use this. I think this is where the error is from. Okay. So it is, since it is C. We say I. And this one too is not supposed to be. It's supposed to just be C. So let's try it and see. So it worked. So when I do ls, I have 4 is alpha. So let me run the 4 is alpha. And what do we have? We have 1 0. So we are good. So let me remove the 4 is alpha. Remove 4 is alpha. And 4 min dot c. Because I don't want to push that. So git add, git commit. So this one I'll just say that when is high or low. We have much to say about that one. So I've pushed it. So let me check the code to see. So we are good, and let's continue. Okay guys, so this one will do the 6th question, which is number 5. Write a function that prints the sign of the number. And we have all the numbers here, right? So we want to print out the sign. Okay, so the first thing is let's write out the name. So it says that the prototype, this is the prototype, it should return 1 and print plus if n is greater than 0. So we just use our if statement to while away this one, and then return 0 and print 0 if n is greater than 0, and then like that. So first thing to do, this one looks quite simple. Copy this guy. I think I've copied it. Okay, let me reload this place. Okay, so let's sit into a let's low level. Right, so let's go. Okay, so vi define 5 times, right? And then uh, we'll include our main.h. Okay, then we add our description. What is the name of the prototype? Let's scroll up. It say int print sign, right? So let me just copy this one because we need everything. Print underscore sign. Okay, what's going on? This is why this guy. What's going on? Why is everything dark? Print underscore sign. And this one say use to print sign of a value. And I'm not sure. Okay, let's first declare the return type. So return 0 or 1 depending on the situation. Anyway, I don't want to be typing too much, so let's have it here. So we are going to declare this int n here. Okay, so let me just put it here. At n is the, I think we have too much space. The value in question. You can add a description to it. Okay, and say n will be used on is the to print. It's going to be too much. Use with condition. Let me just stop there. Okay. So now we have our tab. So if you look at the questions, it says return 1 and print plus if n is greater than 0. So we just write our if, right, n is greater than 0. Okay, if n is greater than 0, then we should return what? We should return 1 and print plus if n is greater. So we want to print plus. To print plus, we come here and then tab underscore put jar, right? Print plus. So come here, then plus, right? And then you should return 1. Is it? return one if n is greater than 0, return 0 and print 0 if n is 0. So we just have an else if here. Else if, right, if n is 0, if n equal to 0, so you can see put char, let's go put char, and then comma, you should return what? You should print 0, I guess. So we'll confirm that, and then it should return, um, it should return 0, right? And then else, we can just end it with else, uh, or we have another else if. Okay, so we're ending it with else, just have else. So we don't, if we are ending it with else, we don't need this curly open parenthesis, right? So we have our underscore put underscore put jar, and then we have this. Sorry, and then we have this, and then I think minus. I'll have to confirm these values, right? And then return a whooping 0, right? -1, okay. Return -1, print minus if I'm 0, and print 0. So this one will be -1. So this one will be, sorry. Okay, we can't use this one to print -1 using ASCII, but the representation of -1 in ASCII is I think 48. So I can just specify that I should return 48. Okay, so what else? What else? Okay, I wanted to adjust this guy. Okay, what else? Okay, let's escape for now, and then let's bet C5. Space required are required on the return statement. Okay, so 11 and 14. Let's VI into it back and see. 11. Which parenthesis is this one talking about? Okay, yes, there's supposed to be space here. 11 and then 14. Let me see. Oh, sorry. We're supposed to have a semicolon here. Right. So let's check now. Yes, so we're good. Okay, and next. So, what else? We want to add that to our main.h, the prototype, right? So we've added it, and then escape. And then what else? Then we can test the program as well and see if it works. So to test it, we'll come here and we'll create five main dots each, or five main dots too, rather. And then I'll copy this guy, paste it inside. Alright, so we'll compile using this. I'll see if you compile or get an error. So it worked. So we'll run this 5 sign. There are plus, negative, 101. And what's this? Plus, negative, plus, okay, plus 0, okay, 101, and then we have this one instead of backslash. So I think this is the only issue we have so far. So I think it's based on that -1 that we represented at 48. So I'll just confirm ASCII. What is the ASCII value of -1? Okay. Let me just use my phone. What is the ASCII value of -1? I don't know this Windows system, all of them, they just hang like crazy. Okay, there is no specific key assigned to -1. Ask American staff. Okay, so he said there's nothing specific for -1. So it's either we print minus and then we print 1. What do you guys think? I think that's the best way we're gonna go about this guy. Because he's telling us there's no -1. Okay, the ASCII table of. Okay, let's see, how do I print? Okay, so I think the best way to do it is just this. We could do it this way. Where is it? Boom. Let's re-enter that 5 sign. Let's see. Okay, so I think the issue is this minus. Oh, we even just root minus. No, this is not the one that's supposed to return 48 now. This one is supposed to be 0, and this is the one that's supposed to be 48. Right? You should return. Where is it? Return. Okay, return should be -1, which is 48, and then that one should be minus. Okay, we are correct. We are correct. Sorry. Undo. Okay, undo. Okay, so return to be 48. Instead of 48, I could just do it this way. So I could just say give a value. So what I'm going to do is I'm going to declare an int to store -1, and int negative equals to -1. Okay, so I'll do this. and then I'll come down and declare a char to hold the, this one is for characters, right? So I'll just say char ch is now equals, I want to give this character ch minus 1. So in order to do that, I'll convert it. Okay, I'll convert it. I'll convert it to that it's equals to, I want to say it is equal to negative. Okay, it's equal to negative, but I'll convert it to char. Okay, so what I did is I gave int minus 1 and I gave char as well minus 1. I gave char ch to be equals to negative, but I converted it here. I converted the negative minus 1 to a character here. So we can then print it out here. So instead of that, put char, you should print minus, so this return type will then become, you should return ch. Right, so let's see. So let's recompile and rerun. So you see we have our forward slash, and then we could run like that. So let's remove that 5 sign and remove the, which other one, 5 sign 5 me dot c, then enter. Okay, so let's clear it. So let's git add, git commit, I'll call it detect sign of a number in git push. Okay, so then let's come check our code to see if it works. My checker is confused about that particular word. What did you just do? Are you kidding me? I don't know why this arrow is not showing though. Okay, for this one, let me refresh the page because this could cause issue of checker not checking. Because that page has been open since yesterday. Okay. Okay, so let's check code now. Okay, let's check. So I think checker is not working for now. So it should work. If it doesn't work, I'm going to make amendments to this video. Okay, so see you guys. Okay, for number 5, so the checker has checked and we have one error here. And if you open the error, it says, okay, that I think that's open. Where is the error? I trace allowed, right? What is where's the error now? Betty coding style? Seriously? So we just have one Betty issue. Okay, so um this should be simple to solve. So let us clear it. Um, ls. So number 5, vi5, or let's Betty it straight. Betty 5, right? Missing a blank line after declaration. Oh, sorry, I didn't check before. 13. So say vi5. Bless you. Sorry. Set number 13 should be here. Oh, sorry. I think this is it. Then so this the nonsense that didn't make it work. Okay, so let me bet it again to see if something else is not wrong with it. Okay, so that's clear. And then git add, git commit. So what is the message for number 5? A function that prints the sign of a number. So copy and then git. What's that? A function that prints, okay. And then git push. I thought we had an error message. Okay, so let's try it again and hopefully it should work now. Okay, checker start working now. I'm waiting. Yeah, so it has worked. So that's all for now. Okay guys, so in this lesson we had to do the 7th task, which is number 6. So it says we should write a function that computes the absolute value of an integer. Okay, so we have the prototype apps, right? So the standard library provides a similar function. So there's a similar function, and then if you man apps, we would see it. So let's quickly man apps and see. Let's clear this one. Right, so if we look at it, you will see apps labs. So it has so many names, and then the house function computes the absolute value of integer argument j. The labs function computes into blah blah blah. So basically you could just read through this with I think this is where it ends here. Okay, so just go through that and then let's quit it. Okay, so now, so we have to compute. So what this one is telling us is that if we have a negative number, we should turn it to positive. Okay, and then if we have a positive number, we should remain positive, right? So in order to do this, copy let me first copy this prototype, right? Or don't let me do that now, we'll do it later. Let's first copy the name, sys apps, right? So underscore apps, right? So sys apps this, so vi name, and then we include our header file, which is main.h. Okay, then is underscore herbs, right? So what is it meant to do? It's meant to compute the absolute value of an integer. Let's just copy this guy. Okay, and then come here, paste it. I hope this thing is not long of an int. Let me just stop at int. Okay, because I don't want it to be too long. And then we can write a description. Okay, so for description you can put you can add this one to it. Okay, that's it. Okay, and this function, you should know that this function, because we are getting too long. And then we'll have an at, right? We're going to have, okay, we don't have any at, so I've copied that one. Our return type is int, so it will return probably 0. And then post put the type. Okay, so this is that. So the next thing is write our if statement. So if we want to know if it is negative and to know if r, wait, int, do we have any value r or something? So let's give it a value here. Let's pass it a value because we didn't have. So let's use r for example. So we'll come here and let's declare it. R will be the value. Okay, so if r is what, is greater than or equal to 0, okay, so if our r is greater than or equal to 0, then it should return, let me read this, yes, then it should return r. Okay, so if it is greater than 0 or equal to 0, then it is positive, right? So you just return the number. Else what? So we can have our else, it should return, we can write it this way, or we could also put our parentheses, stuffs. So in order to not confuse you, you can just do like this. Right. Okay, I hope this doesn't confuse you. So let me just remove this extra space. Okay. And then, so else you should return, so the return statements now, you should return r times, I think, equals to -1, or we could just say So what this one is another syntax to say that you should return r times minus 1. Okay, but for simplicity I can just say you should return r equals to r times minus 1. So it's still the same thing here. Okay, so there's this another syntax of saying this. Okay, so you just say r times, okay, equals to minus 1. Okay, so with this you should be able to check, and then that's all for now. So let me go and put, I think, I'm not sure. Okay, I have to put this one in the main.h as well. So recording now, escape. Okay, 6 apps. Okay, so the next thing is vi main.h, and then we want to put that particular one there. Right, escape. Okay, so this one is done. We clear ls. Okay, so what else? Let's better check it. Number 6. Say you are good, clear, and then we do want to compile it. To compile it, we'll test it out. Okay, so we use 6 main.c and use this code on it. 6 main.c. So let's create a 6 main.c, right? And then we'll copy that in the escape. Then 6 main.c. So 6 main.c, we'll compile. Please kindly let me know on the comment section if you prefer this interface compared to the Vagrant. The Vagrant is a bit dull, but you'll be able to see the cursor. But on this one, the cursor just disappears whenever it's on terminal. Okay, so let's navigate through. What's going on? For more information, did I tell you that I want to? Okay, I said VI. Sorry. I'm just supposed to compile. Okay, so we have an error. So 18 and 20, right? Expression before this. Okay, so 18 and 20. So let's veer into our work. 6 what was that? 6 apps. Okay, 18 and 20. Oh, sorry, vi. Am I sleeping? So I, sorry, escape. 18 and 20. So this 18, okay, and 20. I didn't even read the error message, I just came here. So let me do it without the parentheses first. Okay, I'm sure this one doesn't matter. Let me do them without their parentheses. Let me leave this one in space. Return star equals to minus 1. Okay, or how. So we should just, okay, instead of multiplying with minus 1, we could just say return whatever is there. If this is minus 5 times minus 1, I think this one should work as well, right? So let's try it this way. So let's first dirty it up because we know we are submitting it. So 36. So in case we put some white spaces, Betty would alert us. Okay, we are good. So let us compile it. Okay. So oh, I use that VI again. What's going on with me? Oh, papa. Okay, so it's compiled. So ls and then 6 app. Let's run it. Right. We enter 10198. So we check here 10198. So it means we are good, right? So I want to remove the 6 apps, just the normal 6 apps and the 6 main, right? Okay, so let's clear and then we'll git add it and then we'll git commit. Okay, so we are git committing. Where is it? You can get a commit message from here. There's another way to do it. So instead of direct a function, just a function that, okay, or let's just leave it and then we'll git push. Alright, then we clear and then we'll come to test. The checker is not working yet, so obviously, so we start the test and then once the checker confirms it, you see it in the other video. Okay, so once it's probably 30 minutes to deadline or 20 minutes, it's going to start going. All right, so see you guys. Okay, so we're going to do this one and it says write a function that prints the last digit of a number. Okay, so we have to print the last digit of a number, and that one we just divide it by 10, right? Modulus 10, and then the answer will be the last digit one. So let's just copy this guy first. Mm, right, so yeah, so then first we include our sorry main.h. Okay, then we have this. So what is the name? The name is print last digits. Okay, let me just copy all this guy. Okay, so we have print underscore last underscore digits. So this one is to probably get the last digit of a number. Okay, so you have, it's going to collect a, right, to an integer input, right? You can add a description to it. I could say this is to print the last digit of the number. Um, print with underscore put job declared, and then have we have so we have prints, we have this. Oh shit. And then we have the integer include description, and the return type. The return type should be, you should return last digits of R, right? So then we copy and paste this stuff, and then the code goes in, right? So for the code, we first put our int n, right? Or int r. This one, let's give it r. So they remove that, they are not giving you again, right? So let's save this one as int I, right? So we have our if statement, and we'll put our condition. Okay, so I want to print last digits, so we'll say if r is less than 0, because sometimes the last digit, once it's less than 0, the last digit will be minus, and then that number if we use modulus, right? So we want to solve that. So our n, our I, okay, should equals to -1 times that last number. So this I should be -1 times the last number of r. So the -1 will cancel the negative. Okay, so what is the last number of r? Then we say r times r modulus 10, right? So r modulus 10. Okay, so this one will help us get the last number of this. Okay, so we can have our else. It's just else. Where's my curly braces? Okay, else our I should be equal to just r modulus 10, right? I didn't put my semicolon here. Okay, and then the next thing is then once that is done, you should then print, right? You should print n modulus 10. So our butcher should print I, right? Should print I think we have to should print I, right? I, and then let's return first. If this one doesn't work, then we know what to do. And then we return once we return I, it could be I, but then let's return I. Should we print I and return I? Let's see. So let's try it this way. If it doesn't work, then I'll add the other things I want to add. Okay. So let's veer into the main, and then we put the prototype there. Escape. Okay, so we have our 7, then we vi 7 main dot c, and then we'll copy it in order to test our work. Since checker is not working, so we have to be doing all this ourselves. So we'll copy it, and okay, yes. So what else? 7 main dot c. Let's test it. Did I get it? Let me get it. 7 parentheses are required on a return statement. Okay, that's 23. Yes, 7 print the set number. Oh, sorry. Alright, so let's get it again. And then we are good. It's clear. Yes, and then let's compare. I'm very sure we'll get an error, but I just want to try that out, and then we'll just modify and recompile. Okay, I want to try this out. Okay, let's see. So this one only printed 4, which this one printed 8044. Okay, so we already got one output. Okay, so in order to get it, vi 7 point. So just edit some things down here. Okay, so just a picture. So what we'll do here is we'll say is equals to I, sorry, skip I modulus 10. This one too, I modulus 10. Okay, but before we print, we say print I modulus 10, and then in order to convert this one to an ASCII, we'll add it with 0 like we did the other time, and then we can put this one in a bracket since they are together. Okay, so let's test it now. So 37 print, and then we compile, and then we run. So you can see we have 8044. So vi 7 print. So basically what we added here was that we say we should return, we've declared I, right? Then normally I'm just supposed to say return R modulus 10, but it's going to give us negative. So we use the I to actually save the value and say when R is less than 0, then I should be equals to what is R times minus 1. Okay, so I is now holding the value for R here, and then we did it for here too for positive, right? So since it's holding the value, then we can say it is I now. Okay, so the thing is I has just converted it to positive number. Okay, so it has converted all these things to positive number. So we'll give that positive number back here and divide it by 10 to get the last digits. Okay, and then and then yes, and then print it or return it. I'm not sure this picture is necessary. I'm not sure until I test it out now. And then we have to, because we are printing it out, we have to convert it to ASCII by adding 0 to it. So that will make it work. So we have to, let me remove those remove seven last digits, and so remove 7 okay. So let's git add, let's git commit. What's our commit message? So just copy from here and say a function that printed as 7 number, right? Just paste it, and then we give it push. Okay, so I think in the next 30 minutes. Okay, all the checkers I've checked, so let me see this particular one. Okay, this one didn't check. I think we had an error. Okay, so number five, we're going to correct this error. Okay, so um, let me stop this and then add to number five. So let's run checker for this. I think the checker is back. So this one worked, and then we go back to the number five, and then I'll add the video to number five's video. Okay guys, so in this one we're going to treat number 8, and it said federal agent Jack Brewer, blah blah blah. So write a function that prints every minute of the day of Jack Brewer starting from 0000. We've done this kind of stuff before, but you can listen to this soundtrack where I put it. I don't want to listen anyway. Okay, so mm, so look at when it's executed, the head, the first, and then the tail printed 20 to 59. Okay, so to do this one, what we do is let's copy the name first. Copy, and then preview this, right, and then write include main.h, right? So include our main.h, and then we copy this guy. Okay. So we have this, what's that guy called, Jack Brewer. So this one is not having any parameter and no return type. So we just have this and an end, right? So this one is to print time. We can give it a description, and then print the time in minutes, join false. I hope this is not so long, and then we don't have any return type, so we just end it there, and then we paste our prototype. Okay. So we'll clean this, and so I'm waiting for it to work. Okay, so we're done, and then so what we do next is um, we declare our hours and minutes, right? So we have our int for hours and int for minutes. Okay, so and then yes, so we have two loops. One will go for hours and one will go for minutes. So we'll just repeat the minutes for every hour. That means we'll be repeating the hour 24 times and then minutes will be 60 times, right? So we have our for loop, right? And then we can say as long as we declare each hour is equals to what? 0, right? And then we'll say hour as long as hour is less than 60. So this one, sorry, this one is 24. So this one will go 24 times. And then hour plus. Okay, do that one, write your parentheses, and inside this one we'll have our minutes. So minutes will first go and then will come 24 times. So we'll have another for loop. Okay, let me okay, let me do it this way. Okay, so we'll have our minutes now. So we'll declare our minute. Our minute should be equal to 0 as well, and the minute should be less than uh, minute should be less than 60. Okay, and the minute plus. Okay, so what are we going to do? We're going to print out. Okay, so we are printing out. So we want to print out 1 2 3 4 5. We want to print out, let me go down so you can see 1 2 3 4 5 followed by a new line, right? So we want to print out 16s, right? And then it's going to keep looping. So we'll do put jar 1, put jar 2, oh sorry, underscore put jar, because you cannot use put jar, but declared underscore put jar, underscore put jar, and underscore put underscore put jar 1 2 3 underscore put jar 4 underscore put jar 5 underscore put jar 6. I think it's off now, right? So the last one will house the new line, right? So we just put new line, right? The middle one will house the colon, right? So we put it double colon, right? So it remains this ones for the numbers. So to get this one, we say we the first one is um, hours, right? So we'll say h will be 0 the first time, right? So we want to get 0 0, right? So to get that, we first get the first number by saying h divided by 10. That will give us the first number, right? And then the second number will be h modulus 10. And then to get this one too, we'll do minutes divided by 10, and then we'll do minutes modulus 10. But because this picture will not be able to print everything, we have to convert it to ASCII by add 0 to it. Okay, so add 0 to this one too, add 0, and then this one too, we'll add 0, and then this one too, we'll add 0, and then we can put this one in a parenthesis. 1, 2, 1, 2, 1, 2, 1, 2. Okay, so now let's check our code and okay, so let's Betty, what's it called? Is it 8 24 hours? So we are good. So let us view our main.h and put that header bar, right? So we put that and then save and exit. So we can test our program by copying the main. So we have, what's it called, 8 main.c. So we'll copy this guy and put it vi8 main.c. I'll put this and okay, so we can then compile and see. Okay, and then we do this and press enter. Where's enter? Enter. So when we list it, we have 824. Then we'll run that 824, right? Then you see we printed everything so fast. So I can pass it to this 824. I can pass it to less, so we can scroll through. Okay, where is it? Page up, scroll up, scroll down. Okay, so it started from um, 0 to like that. We got, when we got to 59, got to 1 minute, and then on and on like that, right? We'll do that continuously. So let's quit it and let's clear. So I want to remove this remove the, I hope I don't mistakenly remove what I need anyway one day. 24, and then remove 8 main. I think that's all. So let's just git add, let us git commit with the log the message. So copy it and let's push it and git push. Okay, so let's check our code. Okay, so it worked. So that's all for now. Okay, guys. So in this one, we're going to do the tenth task, which is number 9, and we have to write a function that prints the 9 times table, starting from with 0. So this is the prototype. So it is a void, and it's going to return a void. So let me still leave that one for now because so if you look at the time table, it is separated by comma and I think 2 spaces. Yeah, and 2 spaces, right? So it is separated by comma and 2 spaces. So let's get into it. As you can see, when they translate the space with dots, you can see it has 2 dots, showing that it has 2 spaces in between them, and then it's that. So let's just take a deep dive into it. So for this number 9, let's copy the stuff. Copy this guy and then copy it completely. So copy, and then I'm going to reload this page because it has been open for long and it's not going to work well. Okay, so let me just reload it. Okay, so let's just wait for it to load. Okay, I think it's here. So okay, good. So let's see into the OXO2. Okay, we can't see it directly there. Let me highlight it. Okay, see the ALX low level. We do LS, we see it, CD, OXO2. I don't know it offhand, I would have completed it and it would have taken me there. Alright, so yes. So we want to VI this guy, right? 9 times table. Okay, so the first thing we'll do is include our header file, which is include std sorry main.h, sorry, main.h, right? Okay, so I was just teasing you. Okay, so we have our stuff and the name is time underscore table, right? Okay, and then this one will a function that prints the 9 times table because I don't want it to be too long. Then it collects a void, so we can just add a description and say that for the description, um, it prints it followed by comma and two spaces. I hope this thing is not too long. Okay, so if it's too long, well, the compiler will just, the Betty will just complain, and then I will return in anything. We're not returning anything, so let's go there, and then let's paste the prototype. Oh, this is not the prototype. I thought I've copied it. Okay, so let me copy it. Okay, so void times table void, right? So copy it, and then we'll have it here. Void times table void. So we want to open this guy and then tab it. So the next thing, we're going to have two for loop. The first one, the first for loop would um the main loop which will be inside will print this line, right? It will print the first time table, and then it will get incremented, and then the second outer for loop or while loop will just keep doing this thing: 1 2 3 4 5 6 7 8 9 10. So the outside one would repeat that stuff 10 times, and then the inside one will do what: 1 2 3 4 5 6 7 8 9 10. We'll do it 10 times. So we are going to have probably two for loop or two while loop, or one for loop, one while loop, or one while loop, one for loop. Okay, so for today I'm going to be using two for loop, and before that I want to give some I, J and K, right? Let me just save this one, I, J, K. Okay, okay, so for for okay, and then I'll open my bracket and we'll say for I is equal to 0. Okay, and then I is less than 10 or less than equal to 9. Okay, and then we can say I plus plus. Okay, So we do that, and then we'll have our open parenthesis. So this one will be for the column. So for the row now, so we have the second one for the row, and then we have for I equals to j equals to 0, because they are going to do it 10 times, so we just give it the same thing. J is less than equal to 9, j plus plus, right? Then we'll have its own body here, right? Okay, good. So we are getting there. So the next thing is um I want to repeat this one, right? Let's first go on with what this guy is gonna do. Okay, so for this one, for the first one, let me first do this one. Okay, for the first one, we'll say you should first print 0. As you can see that everything here has 0, right? So after this loop goes, you should first print 0, right? So you should print 0, right? So the next thing is you should print comma and space. As you can see, we have comma and then one single space for now. Okay, so print um, comma, and then you print space. Sorry. Okay, so we've done that one. So the next thing is let me just give this place some space and clean this. Okay, okay. So the next thing is since we've declared that, so we've done the first three. So the next time it's coming, it's going to want to print one. Okay, it's still going to print 0 anyway, because we didn't put I here. So every time this loop goes around 10 times, it's going to print this 0 comma space 0 comma space 0 comma space repeatedly. So it remains this ones, right? So for this one, we would say let k, right? So let me put tab here and put k. So um, let k equals to I times j, or j times I. Anyone. So say I multiplied by g, right? So we initialize that one. So this is where the multiplication starts from, right? So we'll say that, and then we'll now give it some condition, okay, inside. Okay, so before that k can be printed, okay, we'll give it some condition. So we'll say that if, now let me give it some space here, because I don't want anyone to come and shout on me, Mrs. Betty. All right, so we'll say if k is equals to, if k if k divided by 10 is less than 0. So this one, let me just put it in parenthesis. Okay, so what I'm doing is, if k is divided by 10, now k divided by 10 will make us get the first number of this guy, right? So we have to print them separately, right? So because we are using putchar. So if k divided by 0, so for example, where is it? We want to get this 3, right? So we know that the answer is k is 30 already, because we've multiplied those two numbers, right? So we want to print them individually, right? So in order to print them, we have to print this one, but we have to give condition, because sometimes the answer will be the first answer. We don't want the first answer to be 0, right? So we'll say that if k divided by 10 is greater than 0, that's when you should print it, right? But if k divided by 10, if the first number is 0, don't print it, okay? Because uh, from here up onwards, we will not have 0, okay? So if this first number, like for these ones that have first number to be nothing, okay, it means the first number is 0. So if that first number is 0, we should leave it. So this one will serve as the second number, okay? So that's why we leave this one. So this one is having, so this one is 0 0, right? So 0 1. So if the first number is 0, okay, then we should do this. If the first number is greater than 0, okay, so it means it's not 0, right? If the first number is greater than 0, I hope you get this. So if the first number is greater than 0, then we should print, let me give some tab, put okay. So we should print that k divided by 10, okay? So we should print k divided by 10, okay? So I will want to convert it to ASCII so it will be able to print. So to convert it, we just add it with 0, right? So we come here, um, put space, and then add with 0, right? So we'll do this and then we'll end it. So else now, it means that that it means that this space is there, is 0, abi, right? So it means it's less than 0 or is 0. So anything, if it is 0 or less than 0, we should just make it a space, okay? So we'll come here and say else, okay? Else, just print me a space. So we'll tab it, underscore put char, and print us a space, right? Okay, so we are almost done. So we settled that, and then that's printed out. So we now need to do for the second character. We've sorted out for the first character. Let's sort out for the second character, which is k modulus 10, right? To get the second number, the remainder. Okay, so to do that, we'll then say if, okay, then okay, we should do that, and then we should just underscore put char. Then once it's done with the first number, you should just print the second number, which is what, um, k modulus 10. But we have to convert it, right? And then we convert it like this, and then we put this one in the bracket, right? 1 2 3 4 5 6 7 1 2, right? So we'll put this in a bracket, and then it should work. So k, oh sorry, this one is not underscore, picture is dash, put direct, so underscore. Okay, good. So I think with this we are almost done. Okay, so the next thing is we've printed this one. So the remaining thing is for it to, so once it prints the first value, we printed this one, we printed this one, right? So the next thing is to make it, this comma and space should stop at whenever it sees um what's it called, whenever it sees 9, right? Because majorly I think it's stopping there. Yeah, so whenever I get to the ninth position, okay, so all this ninth position, they don't have comma and space, so we just want to put that condition, okay? So you come, are we coming down with this loop? Yes, we should come down. So let's come down like this, and we'll say if, or let me put it out there. So if our c is, I say c, if our j, which is this inner loop, right? Okay, is less than, because it's j that is printing rows. So if our j has gotten to 8 and is going to 9, so when it gets to 9, before it gets to that 9, so it's to do all these things for only the first 8, the first 9. The 10th character will not, it will not execute this code. So we'll just say that you should print comma and space. Okay, so we'll say, then we can put our curly braces if you want, and then you say you should print underscore put char underscore put char. Then we'll say you should print, is it the same? I wrote put char twice, underscore put char print. So we should print comma and then space. Okay, comma space. Okay, so, and then at the end of it, you should end it with a new line. So I think this one is for this one is for this one. So outside this place, we'll have a new line here. So underscore put char, and then this, and then our new line. Right? So I think basically this is it, and let's see so far. Okay, let's just hope this works. So I'll exit and then go to my main.h, right? And then add the next stuff into it. I'll add this one, times table, right? And then save and exit. Okay, so let's Betty it, right? So to see if we, so we have trailing white space at number 22. So vi the 9, and then okay, sorry, let me set the number, and then we have 22. So I'll go to my 22 and then insert mode. Okay, I definitely have here, and I've deleted them, right? So let me try again. So let me Betty again, and okay, we are good. So let's clear it. So in order to test our work, we'll do like this and create a main.c file, and main.c file. So this is 9 main.c. So we'll create that file and copy this guy. Copy. Yeah. vi9 dash main.c. Paste it, and then we'll do like this, and then we'll compile to see if we do not make any error. So this will make our work well. So copy, and then we'll paste to compile, and I think our compilation works. So when we do ls, we have this 9 times table, so let us execute it, right? So we have 0 0 0 0 0, but the problem is it's not printing a new line to I think it dipped to 81. So let's check. So it actually did it to 81, but I think after this place we are supposed to have a new line. Okay, so we'll just add that new line, and then we should be able to work well. So yeah, so that's just it. I think the new line we put was not supposed to be, it was not in the right place. So let me vid 9 what's it called again, 9 times table dot c, right? So I'll come here, and then this new line, I'll take it up. Okay, yeah, it's supposed to be after, not after everything, after the first loop, right? So I'll just bring it here, and then underscore put char, and then new line, right? Okay, I hope we don't have so we have to bet it first because 9 times table, let's see. So better say we are good, then we'll recompile it. Okay, let's recompile and then let's re-execute it. So we have it, right? So after everything. So I think it's working fine now. And yes. So basically that's it. And we could still run this second code on it. Where is it? This second one. And then it's going to print. So we translate it and cut it. Okay. So if you do this and then you press enter, you still have this, right? So that will be all for this. See you in the next video. So we forgot to actually git add and git push. So I git add, right? Um, git commit -m, and then the commit message. Let's give it this. So let's give it a commit message, right? A function. Let me just copy this. Alright, copy. You can start with a function, okay, to make the English easier. And then let's git push, right? So let's clear. So when I run my checker, you see that there's an error, which I think I did before continuing this. Okay, so I just want to show you that there is an error. Okay, so there's an error which says that when we checked it, we had more outputs than normal. So our own is 1, 2, 3, 4, 5, 6, 7, 8, 9. No, not this. Let me run the checker again. So we have this error. So let me see. Okay, so if you check the error details, you see that the output is may more than normal. So this one is having extra one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it means our inner loop is going more than usual. Alright, so we have to reduce it to 1. And if you notice very well, um, we have this 0 repeating twice. Okay, so that's what we want to reduce. So in order to do that, we go back to our web terminal. Hey, I hope this thing works, because this is how it freezes. I was like doing the video and then it crashed, so I had to start all over again. That's why I had to show you. Okay, so I hope this works. Look at the way that parrot is shouting. Okay, so let's VI into our 9. Okay, so what we just changed here is the inner for loop is going more than expected. 0 to 9, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think it's going to be 1 to 9 then. So let's reduce this to 1 to 9. Are we in insert mode? So let's change this one to 1. And then let's git add, git commit, and then git push. Okay, so let's check our code now and start a new test. So we are good. So that's it, and yeah, see you in the next video. So today we'll be doing number 10, which is 11th task, and it said write a function that adds 2 integers and return the result. So this one is quite easy. So there are different ways to do this, and let me just copy this and okay, so let's copy this first, and then so let me clear my screen. So I'll put that in the main.h, right? And then insert, oh yeah, Okay, so escape. So let's write our function now. What's going to be the function? So this is the function in 10 dot c. Let me just type it. vi 10 dash add dot c, right? So I'll include that header main.h, and then I'll do this, right? And then we have, what's the prototype called? Let me just paste it, add. So it's called add. So add is sum up two integers. So let's give it a, I think it has a return, right? It has int, it has a return, so it should return one. And then let's give it a description. And let's call it to description. I hope I got it right. To add two integers. Nothing much. So let's just add. So we have an at, right? So we are going to have an integer here. So let's just add a and b, right? So let me just go back. So I think I have a white space here. Let me just remove it. Okay. And then at a, this one will house the first integer, and then we'll have another one b. This one will house the second integer, and then we'll have our return should return a 0, and it's okay like this. Then let's put this, and then so it's going to return 0, and then let's give this one int a and int b. Okay, so and then we'll go, and then this one should, you can just declare, oh, int b, we didn't put space. You can just do this, and then int b, I can just say our result should be, let's declare an integer called result first. Int result. Okay, so I can say int result is equals to a plus b, right? And I can say it should return results. Okay, so another way to do it, instead of writing all these jargons, I can just say return a plus b. Okay, and this one too would definitely work. Okay, so you can just use that, return a plus b. So let me just escape this, and then okay, so this one we can test it by, okay, I haven't used Betty to check if it's correct, but we'll create a 10 main.c and then use this stuff to test it. Okay, so I'll create 10 main.c. I'll use this one to test it, and then we should have, what is 98 plus 9? It should give us 98. 89 plus 9 should give us 98. So 10 main.c, and so let me test Betty 10 ads, right? So Betty say we have a blank line after declaration 15. So let's go to 15. Sorry. Okay, I think I've gotten what Betty is saying. Is this place. So we just put a space. So okay, so when we do Betty again, it's correct. And then let's create vi 10 main.c in order to test our code, and then we paste it there. Okay, so let's compile. To compile, we just copy this guy, and the answer should give us 98, right? Copy, and then let's paste this. And then when we do ls, we should have 10 add, right? So let me clear and let me execute that 10 adds. So we should get 98, which is correct. Okay, so let me list and remove those 10 main and 10 adds. 10 add. Okay, so remove those ones. So let's git add and let's git commit and say add to integers, right? And then let's git push and then let's check our code to see if it is right and go to the next one. Okay, so it worked.